All right, so let's pick up the internet protocol, IP, right? So we've been looking at IP since when you were configuring PCs, you go to the IP configuration. So now we're going to look at the purpose of an IPv4 address, binary conversion of an IPv4 address, the IPv4 address structure, classical IPv4 address, right? Uh, the public and private IPv4 addresses, and the unicast, broadcast, and multicast addresses. IPv4 addresses have different types, right? Different classes, and there are also specific classes, okay, that are made for specific things. Me, let's go further. So the IP address, okay, or your IPv4 address is actually what represents a particular host. So it can represent your laptop, it can represent your phone, it can represent your printer, it can represent any host device at all. Any device that can send and receive information. And IPv4 address is what that is what is given to that system, so that that system or that host machine can be identified on the network. So that IPv4 address is actually assigned to the network interface of the host. All right. Remember, I talked about the NIC, the network interface card. So it can be wired, it can be wireless. All right. So your wireless card is what is assigned that IP address, not actually the system. Just so you know. Okay. So router interfaces provide connections to an IP network will also have an IPv4 address. So before you can have an IP address, so your router also would have an IP address. So have its own IP address. So every packet that is sent across the internet has a source and destination IPv4 address. So you want to send a message from your system to my system. So your system is going to be the source IP address. Alright, so you're going to have the source IP address and you're going to send it to me. So you're sending to my IP address, which is going to serve as the destination IP address. So required by networking devices to ensure the information gets to destination and replies are returned to the source. So that's just what the IPv4 address does. So it's required by networking. So there's a lab there will be doing that you have access to. Let's look at the binary conversion of an IPv4 address. So IPv4 addresses, all right, are of 32 bits binary number. So 32 bits of zeros and one. So right here, let me use the marker. We have 32 bits. So we have 8 bits here, 8 bits here, 8 bits here, 8 bits here. So this 5 that you're seeing here is 8 bits. So 5 in binary is what? If 1 is 1, 1 is 1 0 is 2, 1 1 is 3. So 1 0 0 is 4, 1 0 1 is 5. So what we'll be having here is like 1 0 1, then 0 0 1, then you convert this one to binary. So you get, so they're about 8 binary digits, all right, for each section. So that is it. So you can see here now, it says that the this 192.168.1.5 is equivalent to what? This long binary digit here, right? So if let me use my pen to separate it for you so you can see. So you can see we have the first four, which is 1011. So if you want to pick the first eight, so this is what this particular frame I selected, it's for 5, all right. Then for the next one we have what? 1 2 3 4 5 6 7 8. So that is for what? 1. Are you saying in binary, you see that it is still 1, and 1 in binary is still 1, right? So we also have 1 2 3 4 5 6 7 8, which is what? For 168. So if you convert 168 to binary, you're going to have exactly what is here. Then for the last one, okay, we have what? 1 2 3 4 5 6 7 8, and that is for what? 192. All right, so that is exactly how this IP address here was gotten. So now you say that to make the IPv4 address easier to understand, each octet is represented as its decimal value, separated by a decimal point to the point of period. That's so that you can easily understand it or easily uh, memorize it. So it's easier to memorize 192.168.1.5 steps than memorizing 1000000010100100000. Just imagine how long. Imagine you're not going to write. It's even easier typing this particular one here than having to type this when you want to assign an IP address. Imagine you have to type this to assign an IP address. So that's going to be really, really crazy, right? So let's go further. There's a video on the website for you to watch. All right, let's look binary to decimal. So you can actually convert binary to decimal. You should know how to do that in normal math. So when each octet is made up of what? 8 bits, right? So if you're converting from decimal to binary, you have to keep them in 8 bits. So that means eight, you are keeping 8 spaces, more like you have for example, you have 8 bits are what? Ones, like one, two, three, 4, 5, 6, 7, and 8. So if it's 0000, it is what? 8 zeros, right? Just like we have here. Okay, so now if there is a zero in a position, do not add the value. So if all 8 bits are zeros, the value of the octet is what? 0. If all 8 bits are ones, then you have what? 111. The value of the octet is what? 255. So 255 is the maximum number you can have. All right. Now, if the 8 bits are mixed, such as the example 001001111, the value of the octet is what? 39, which is what? 32 plus 4 plus 2 plus 1. Do you understand what that means? So you just convert this to binary easily. Just convert 39 to binary. You're going to have this. All right, look at the breakdown of binary to decimal conversion. Now we have this is the octet bit values, okay, and this is what the binary address and binary bit values. Okay, so here now, let's say we want to have 192. What gives 192 is what? Which is 1288 plus what? 1 plus 64. You get what? 192, which is this. All right, then in binary, 1000000 is what? 128. Then 0 0 1 0 0 0 0 0 is what? 64. Then you have 0 here. That means 0 0 0 0 0 is equal 0. So the same thing here. When you have 1, then 7 zeros is what? 128. You have what? 2 zeros before 1 and what? 5 zeros. Yeah, that's what? 32. So that's what? 32 down and this one. So once it's just they're just making the math easy for you.
Your voice is
Okay.
hello.
Yeah, I can hear you. Is
Okay, your voice is easy.
is it still breaking now? Is it
No.
all right? So now if you have just know that anytime there's a 1 here, you have what? 128. If there's another 1 here, that's going to represent what? 64. So they're telling you that for every 1 in these 8 zeros here, if there's a 1 here, all right, it means that the value here is what? 1. Then you just bring it down what you add. If there's a 1 here, the value here is what? 2. If there's a 1 here, the value here is what? 4. If there's a 1 in the next one, the value is what? 8. So just like here now, there's a 1 here, which means the value is what? 1. So you carry the 4, right? You now carry the 4. If there's 1 here, the value is what? 1. So you add the 4 plus 1, right? That's how we get what? 5 to decimal. That's exactly how the calculation is. So they're just making it easier for you to calculate. So you can either do that or you just convert the whole number to what? Binary, and you're going to get the binary value. So now, if you wanted to do this, all right, and you wanted to convert this to binary, all right, convert this number here to binary. Okay, what you would do here is just write 128. Let me just do the calculation here. 128. Then you also have 64 plus 64. This is a 2. You also have one here plus 32. You also have one here plus 16. You have 0, all right? Then we have 1, which is plus 4. Then we also have 1 here, which is plus what? 2. The value here is 2. So when you add everything here together, this is 12, 14, 16, 16 plus 18. That is what? 24, right? Sixteen plus 8 rather. That's 24. So we're going to have 4, right? Carry 2. So we have 4, 10, 14, right? So that's 4. And we have what? 244. So 244 is going to be what? Our value here. All right, so now we have to convert 90 to what? Decimal. So you just do it the reverse way. You know the way to convert decimal. You just keep dividing by 2. So you keep dividing by 2. You do 2 in 90. You do it remainder. You put the remainder. Continue like that and so on. All right, let's not waste so much time on that. Let's move forward to IPv4 address structure. So the logical 32 bits IPv4 address is hierarchical and is made up of two parts. So which is the network and the host part. Network portion and the host part. So both parts are required in an IPv4 address. So as an example now, let's say we have a host, okay? So we have a host with this IP address, say 192.168.5.11. So we have what? A subnet mask of 255.255.255. So now we're going to what? Understand that this subnet mask that has 255 at the point where the 255 stops, all right, that tells that that is the network portion. So now you see the first 3 octets, 192.168.5, identifies the network portion of the address, and the last what? Octet, which is what? 11, is the what? Host portion. All right, so how do you identify the host portion? Because of what? This subnet mask. So wherever you have your 255 ends, that's your network portion, okay? And the other part is what? The host portion. So this is known as hierarchical addressing because the network portion indicates the network on each unique host address, on which each unique host address is located. So routers only need to know how to reach each network rather than needing to know the location of each individual host. So now with IPv4, with IPv4 addressing, multiple logical networks can exist on one physical what network. So if the network portion of the logical network host address is different, the host with the same network number in their before address will be able to communicate with each other, but will not be able to communicate with the other host without the use of routing. So you can see here now, these are two routers, right? This is router one, this is router two. So if you notice now, we have 192.168.18, which is this network. All right. We also have 192.168.5, which is another network. So every host device on this network will have what? 192.168.5. Then whereas every other system on this other left network, all right, will have what? 192.168.18. Then for the different hosts, the host number will be changing. So we have 0 here. You can see we have 99 for the router already. We have 0 for the switch. All right. We have 33, 32, 11. And for the right network, you can see that their host is also changing. So we have 33 here, we have 22, and we have what? 11. All right. So you can see the label here, network number and what? Host number. So which means that this system on this part now can communicate with every system here, but on the other hand, it can't communicate, this system can't communicate with the system here. So if it tries to communicate with the system here, it's not going to work. All right, it can't work directly. All right, it has to go through the router instead and come to this router, okay, before this router now what? Communicates with it through the switch. So it passes through the switch and before it gets to what? This particular host. So this is logic AND. So the logical AND is of three basic binary operations used in what? Digital logic AND is used in determining the network address. So logic AND is a comparison of two bits that produce the result. All right. So in AND, all right, when it comes to the AND gate in computer, all right. So it's just like having um, a bulb controlled by two switch. Let's say this is the first switch, all right. This is the second switch. So and we have our bulb here. All right. So that's our bulb. So let's assume the switch at the bottom part, all right. The switch at the top part is what? Switch A, and switch at the bottom part is what? Switch B. All right. This is the bulb. So let's call this our bulb L. So now, if I wanted to turn on the bulb, all right. So if I was going to turn on the bulb, let me erase this. So turning on the bulb now means that both switch must be on. So let's now draw a table. All right. We have switch A, switch B, and the light L. So if switch A was on, which is 1, let's assume 1 equals on and 0 equals off. All right, so it looks like, okay, I thought someone was raising a hand. So now, if first switch A was on and switch B was off, it means that power will not be able to uh, power will be able to what? Come to the bulb, because let's say assume there was a battery here. I didn't add that. So let's assume there was a battery here. So if switch A was on, all right, and switch B was off, all right. So the power is going to what? Pass through switch A and turn on the bulb, right? So which means we automatically have what? On for the bulb. So if switch A was off, all right, and switch B was on. So even if switch A is off, all right, switch B is on, which means power can still pass through what? Switch B, and which means the bulb is going to what? Come on. So if both of them were off, all right, if both of them were off, there will be nowhere for power to pass and turn on the bulb. So which means what? The bulb was off. But if both of them were on, means that power even have what? Two ways to pass, and what? It's going to be what? On. All right. But now this is when it comes to uh this is when it comes to okay, this actually is for the or. Oh my god, I just realized I did for the or gate. So this is for the or gate. But now let's do for the and. All right. The correct uh the correct diagram for the and, all right, is what I'm going to draw now. Let me draw the one for and. All right, so for the and now, let's assume we have our battery, we have our bulb. So for the and, it's going to appear like this. Let's say we have switch A and switch B. Okay, so this is our bulb. Our bulb is L, and this is what? A, and this is B. So we have one signifying on and the other one zero signifying off. So you have what? A, B, and L. So let's just do when A is off, B is off. When A is off, B is on. When both of them are off, and when both of them are on. All right. So now, if A was off, all right, if A was on rather, and current passes to A, when it gets to B, current is not going to pass because B is off. So which means our bulb is not going to work on, right? When A is off and B is on, right, the light power won't still be able to pass. So which means our bulb will still be what? Off. When both of them are off, obviously power is not going to pass, which means our bulb will still be off. But when A is now on, all right, and B2 turns on, okay, that is when our bulb will not be able to work, come on. So which means it's until we have both of them on, that's when we're going to have what? On. All right, so sorry about the odd gate I did previously. So this is for the correct circuit diagram for the AND gate. All right, so to identify the network address of an IPv4 host, the IPv4 address is logically ANDed bit by bit with the subnet mask. So ANDing between the addresses and the subnet mask yields the network address. So now look at it. We have the subnet mask. All right. When we do the IPv4 host address, let's assume this is our host address. All right, and this is our subnet mask. So remember, it's 255. 255 means that all bits are full. All right, so they are all on. It's 1111 8 times, 111 8 times. So when we do 11000000 and 11111111, okay, we're going to have what? 1 and 1. So 1 and 1 is what? 1. Remember, and both of them must be 1 before you get 1. 1 and 1 is what? 1. All right. So 0 and 1, 0. 0 and 1, 0. So you can see we're going to have the same thing here. All right. 192. So the next one, 1 and 1, 1. 0 and 1, 0. 1 and 1, you have what? 1. 0 and 1, you have what? 0. 1 and 1, you have 1 and 1 again. You have what? 1. Alright. 0 and 1, 0 and 1, 0 and 1. Automatically, you're going to have what? 0 because you have 0 and 1 here. So you do the same thing, you get this one. But when you now do this, okay, 0 and 0, 0, you can see three zeros, four zeros rather, will use what? Four zeros. Who's going to use what? Four zeros here. But now, when it comes to this 1 and 0, 0, you can see 0 and 1, 0. So because we have all up here, it means that we're definitely going to have what? All up here. So that tells you that this portion, all right, is our network address, all right. It tells you that this portion is our network address. Let me just highlight that properly. So it's our subnet mask that is used to help us identify our network portion. So how do you calculate whether the destination is local or remote? Now, when something is local, it means that it is connected directly to the same network. But when it is remote, it means that it will need to pass through a router to connect to the other host. So if I'm connected to you locally, it means that we are either connected to the same router, okay, or we are connected to the same switch, all right, or our system is connected to each other via an Ethernet cable. But if you are in Makurdi, I'm in Port Harcourt, all right, my let's assume this is PH, all right, and we have Makurdi, let's call it MK. Before I can be able to connect to you, all right, I can't connect to you directly, all right. We are going to it's not going to work. I will need to pass through a router, all right, that will come here first, and before it will now route the network back to you, because my network address can be 192.168.1.0. Your own network address can be 192.168.2. That shows that you're on a different network, all right, because you are on a different host network. So if we are connected together, for example, you are seeing these two switches, they are connected together, so you can see that their network portion is the same thing. The only thing that might change will be what? Their host portion. All right. For example, you can see this one, the host portion is what? 44. The host portion of this one is what? 66. But their subnet mask is the same thing. Hence, they are on the same network. Okay, now the subnet mask I've told you that what this is the network portion. So now the subnet mask signifies which part of the IPv4 address is the network and which part is host. So the subnet mask is compared to the IPv4 address from left to right, bit for bit. So the ones in the subnet mask represents the network portion, the zeros represent what? The host portion. So when a host sends a packet, it compares its subnet mask to its own IPv4 address and then the destination IPv4 address. So if the network bit matches both the source and destination host, matches, okay, if the network you match, okay, both the source and the destination host are on the same network and the packet can be delivered locally. But if the network bits do not match, the sending host forwards the packet to a local router interface to be sent to the what? Other network. This is exactly what I explained here. So how do you calculate the number of hosts? All right. So for example now, how do you calculate how many hosts are on a particular network? All right. So now we have this. So this 255.0.0 are 8 bits. 255. 255.0.0 is what 16 bits. 255.0.0. 255.255.255.0 is what 24 bits. So a subnet mask of 255, all right, of 24 bits, all right. This is in decimal, all right. Remember that this is the same thing as having this, all right. It uses what? 24 network bits and what? 8 host bits. So to determine how many hosts can be on that network, take the number 2 to the power of the number of what? Host bits. All right. So if the subnet mask is this, all right. So the number of host bits is what? 8. All right. Remember they say that this one has a number of how many host bits? 8. Because when you count how many eights are here, how many zeros are here, you have one, two, three, 4, 5, 6, 7, 8. So when the last bit stop here, we have what? 8. So you have to do 2 raised to power 8, which means we can have 256. So now you subtract 2 from what? 256 for numbers that cannot be used. So which means these two that you're subtracting, okay, one is the broadcast address, okay, of all ones in the host portion, and the other is what? The network ID for all the what? Zeros. So another method again that you can use is what? To add all values of the available host bits. All right. So when you do um this, all right, you're going to get 255 and subtract what? 1 from the 255. So you have 254. All right, because all host bits cannot be all ones. All right, so that the best method, like what I usually use, is this particular one here. All right, to determine how many networks. So by the time you convert the um, subnet mask, okay, not necessarily the subnet mask, the network, okay, the network portion or the network IP address to binary. So even if it stops here, let's say the one stop here and this one was 0, all right, you will now do what? 2 raised to power, it no longer be raised to power 8, 9, to become raised to power 9. And when you get your answer, all right, you just subtract what? Subtract 2 from it, and you're going to get the number of IP addresses or the number of hosts that can be connected to that network. All right, so this is another activity. So let's look at classful and classes addressing. So this is a class A IPv4 address. All right. So class A IPv4 addresses, all right, range from 0.0.0.0 slash 8, all right, to 127.0.0 slash what? 8. So designed to support what? Extremely large networks with more than what? 16 million host addresses. It used a fixed what? 8 prefix, which is what? This particular network or subnet mask. So now we have class B. So class B is what? 128.0.0.0 slash 16, 191.255.0.0 slash 16. So this one is designed to support the needs of moderate to large networks with up to approximately 65,000 host addresses. So it's used a what? Fixed 16-bit prefix. So which means the network address is going to be what? 255.255 for this class B. So how do you know the class? You can just find out by what? The what? Subnet mask. Therefore, class C now, we have what? 192.0.0.0 slash 24 to what? 223.255.255.0 slash 24. So it's designed to support small networks with a maximum of 254 hosts. So it's used a what? Fixed 24 prefix. All right. So note that there is also a class D multicast block consisting of what? 224.0.0 to what? 239.0.0, and the class E experimental address, it consists of what? 2.240.0.0 to what? 255.0.0. So just take note of these ranges here so you can easily identify the different classes of network or IPv4 addresses rather. So you can see that they have different uses. When your network is for over 60 million people, you will use a class A IP address. When your network is for um, at most 65,000 people, you use a class B. But the one that is common is a class C IP address. That's why even when we're working with packet tracer, the IP address will just put sharp sharp is 192.168, 192.192.192.192. So we're 192 points. All right. So right here in this pie chart, you can see that um, class A covers about half. All right. Class B covers with 25%, class D 12.5, and class E, which is for the experimental multicast, is what 12.5%. So you can see total number of networks, total number of hosts. So class C, you can have a maximum number of 254 hosts on a class C network. So look at public and private IPv4 addresses. So public IPv4 addresses are addresses which are globally routed between ISPs. ISPs is internet service providers. Okay, so the ISP are actually routers. So the next, then the private addresses were introduced, okay, because of the depletion of what IPv4 address space. All right, so IPv4 addresses are not unique and can be used by an internal network. So specifically, the private address blocks are okay. So a private IP address is what 10.0.0.02 or 10.0.0 to 10.255.255.55. Now this is for class A. 172.16.0.0 to 172.331.255.55 for class B. Then for class C, which you should take note of, so class C private um, IPv4 address is what 192.168.0.0 to 192.168.255.255. So note, private addresses are defined in RFC. All right. All right. So the RFC is just uh, request for comment. All right. It's just an organization that notes the internet standards or that sets internet standards. So they cover different aspects of computer networking and they cover and the people just and people refer to the IFC for IP address or IP protocol implementation, right? In case there's an issue, you just contact the IFC. All right, so now the IPv4, still more on the private IPv4 addressing. Now, most organizations use private IPv4 addresses for their internal hosts. However, this uh, RFC, okay, 1918 addresses are not routable in the internet and must be translated to a public IPv4 address. Okay, so network address translation, which is NAT, is used to translate between private IPv4 and public IPv4 addresses. So it's usually done by on the router that connects the internal network to the internet service provider's network. So home routers provide the same capability. So you can see here now, these are different systems on different networks. All right, and this you see it says, let's say you're sending a message here. All right, it says what this packet has a source IPv4 address that is a private address. I will translate it to a public IPv4 address using what network address translation. So assignment of IPv4 address. All right, so an organization that's responsible for that, and they are the IANA. All right, so the IANA manages and allocates block of IP addresses to the regional internet registry, so which is the RIRs. So RIRs are responsible for allocating IP addresses to internet service providers. who in turn provide their IPv4 address blocks to organizations and smaller internet service providers. So organizations can get their address directly from the RIR's um, subject to the policies of that RIR. So let's look at unicast, broadcast, and multicast addresses. So now unicast. Unicast communication is used for normal host to host communication in both a client server and a peer-to-peer network. So the unicast packets use the address of the destination device as the destination address and can be routed through an inter-network. All right. So let's look at this now. So it says during the encapsulation process, the source host uses its what IPv4 address as the source address and the IPv4 address of the destination host as the what destination address. So regardless of whether the destination specific whether the destination specified what a packet as a unicast, broadcast or multicast, the source address of any packet is always the unicast address of the what originating host. All right. So now this is this host 192.168.116.4.1, all right, is sending a message. Now the router will or the switch now is going to perceive that the source is what 172.16.4.1, right, and the destination is what 172.16.4.253. So this is the destination. The destination is what the printer. But now for broadcast packets are sent to all hosts in the network using what? A broadcast address. Now a broadcast packet contains a destination IPv4 address with all on ones in the host portion. So when this host here wants to send a broadcast, all right, the switch reads what the source as the IP address of this host, which is the sender. And now the destination is going to be 255.55.555, which is going to be what the broadcast address. All right. So which means that it's going to go to everybody on the network. So by default, routers do not forward broadcast. Routers can eliminate excessive broadcast traffic by subdividing networks into separate broadcast domains. All right. I explained this in one of the videos on YouTube. You could go ahead and watch that. So let's look at multicast transmission. So multicast transmission reduces traffic by allowing a host to send a single packet to a selected set of hosts that subscribe to a multicast group. Okay, so IPv4 has reserved the 224.000.239.255.255 addresses as a multicast range. So the IPv4 multicast address or addresses 244 to 244.0.0.255 are reserved for multicasting in the local network only. So a router connected to the local network will not forward them for that. So multicast is when you want to send a message from this particular system now to two different systems at the same time. Instead of sending it to others, so you do not want others to receive it, you actually will send it using a multicast. So hosts that receive multicast are called multicast clients. So the multicast clients use service requested by a client program to subscribe to the multicast group. So each multicast group is represented by a single IPv4 multicast destination address. So this is just simply like when you subscribe to receive emails from a particular website. They say, do you want to receive an information or do you want to be receiving updates? You just go and check the box and submit. So once you have done that, you are subscribed to um, the multicast service. All right. So that's why you will now see on your emails you say unsubscribe. So unsubscribe means that you are removing yourself from that particular network. Because if you are still on that particular network, it means that anytime a message is sent to that particular IP address, all right, everybody on that network will receive that information. All right, so we've understood IPv4 address, we understood what the difference between multicast, unicast, and broadcast. All right. If you look at the different classes of IP address, class A, class B, class C, we've seen the private IP address, right? So there are also some things that you should take note of, right? So let's move to the next, all right? So we're going to, all right, the module 9. Dynamic addressing with DHCP, all right? So we look at static and dynamic addressing, look at DHCP v4 configuration. So let's look at this. So IP4 addresses can be assigned either statically or dynamically. So when it's static, it means that you are putting it manually. You are assigning the IP addresses manually. So with a static assignment, the host IP4 address must be configured manually together with subnet mask, default gateway, and DNS server address. Then the static addresses are typically assigned for printers, all right, servers, and other networking devices that need to retain a fixed IP address to provide services. So static assignments can be time consuming to implement, so it's prone to error because manual configuration is required. All right, just imagine you wanted to assign IP address. Okay, you wanted to set up an exam hall for um, JAM. You're now going to start fixing IP addresses for all the systems. For over 150 systems, you're going to get tired, right? That's why it's not just advisable to use static. But when you're working with a home network, like in your house now, there's not be a network in your house, you can now use static because you can just do everything manually. And when there's a problem, it's easy for you to find and debug where the problem is. But in a case where you're having over 100 hosts to be connected to a network, if one has a problem, it will be very hard for you to troubleshoot. But the dynamic now can be dynamically assigned to end devices through an application protocol known as the Dynamic Host Configuration Protocol. So the DHCP automatically assigns addressing information such as IPv4, subnet mask, default gateway, and other configuration information. So the benefit is that it reduces the burden on network support staff and virtually eliminates entry errors. So dynamic IP address is not permanently assigned to a host, but is only leased for a period of time. All right, so to set that up, you just need to open your IP protocol. I've opened this before. I've showed us how to access this. You just use this. All right, once you click on obtain the IP address automatically, this is already using the um, dynamic host configuration protocol. So now there are DHCP servers. All right, so DHCP servers, okay, run on networks. All right, so a device can be a DHCP server if it's running the DHCP service software. All right, so it's a DHCP service software that enables a device to act as a DHCP server. So DHCP v4 servers are typically connected to a LAN because it uses what broadcast. So DHCP version 4 servers, that's what v4 means, deployed outside of a LAN will require relay services. So in a home network or small office, home office network, a wireless router provides DHCP service to end devices. It is also a DHCP client to get IPv4 address from the internet service provider. So just like you have here now. So this is a DHCP client, all right, and she's using mobile network, all right. So once she sends information, it goes through a a mast and get towards the DHCP um, router server, right? Which is the ISP1. You have ISP2, you have ISP3, okay, and then she can be able to communicate on this particular network. So there's a video on how to configure a DHCP, but you need to know that when a host is configured using DHCP, it will try to obtain an IPv4 address subnet mask before gateway and DNS server from a DHCP. So how it is done is that the client sends a DHCP discover message using broadcast. So a DHCP server now responds with what? DHCP offer message with a set of IPv4 addressing information. So the client then sends a DHCP request message to request the use of IPv4 address information offered by the HHCP server, right, which is the static um, HCP server, right? Host, that static host configuration protocol server. So the DHCP server responds to the DHCPACK message, okay, to grant the request from the client. Alright, so this is DHCP server, this is DHCP client. So DHCP client, for it to be a DHCP client, you just need to go and select that dynamic get IP address dynamically on your system. So DHCP service configuration. So to configure a home wireless router, alright, you just access the graphic user interface, access its graphic uh, user interface, just like your router now. In MTN router, you just go and type, you open your browser and type 192.168.0.1. It open the, that's like the default gateway of that particular router. It open up the GUI. So the IPv4 address of 192.168.0.1 and subnet mask of 255.255.45 are the default for the internal router's interface. So this is the default gateway of all hosts on local network. Ensure that your DHCP server is enabled. So specify the DHCP IPv4 address range with a starting address. Do not use 192.168.0.1 because the router is assigned this address and the number of addresses to be assigned. Alright. So which means all hosts must have host 192.168.0 as their network address, as long as they are connected to the same network. Alright, so we've understood a few things about DHCP and SHCP. Alright, so DHCP is dynamic, SHCP is static. Alright, now know what a DHCP client is. That's clients that request for dynamic IP addressing, and a DHCP server is one that supplies IP address to a DHCP client. Right, and DHCP discover is what the client, a DHCP client would send when he wants to receive an IP address, and when the DHCP server responds with DHCP offer, he offers a pool of IP before addressing information. Then the DHCP client will now send a DHCP request to select IP4 address, and the DHCP server will now send back a DHCP pack to that particular um, DHCP client. All right, so that's all for module 9.